Hello, everybody. Welcome to another Hoot episode. Well, GraphQL is cool in providing the exact data of what clients ask for. Does GraphQL help front-end developers or back-end developers? What about operators? What are the challenges in adopting GraphQL? In this Hood live stream, I am so excited. Keith Babo is joining me to actually teach me a lot of things about GraphQL, the landscape, and the challenges in adopting GraphQL, and also some of the innovative solutions out there to tackle these challenges. So, Keith, could you quickly introduce yourself?
Yeah, hey Lynn, thanks very much for having me. So my name's Keith Babo. I'm a product manager here at Solo. I've been at Solo since November of 2021, I guess. It's been a fantastic ride here. Before that, I worked at Red Hat for maybe, I think, 13 years or so. Did a lot of things in managed cloud services, integration technologies, a lot of API management and RESTful APIs. Really, really excited about the opportunity that GraphQL creates in the API landscape. So happy to talk to you about it here today.
That's awesome. We are so excited to have you, kids. Well, I guess you hit your anniversary with Solo soon in the next few months. Yeah, I know I just had mine. So before we get to GraphQL, I'd like to quickly cover a couple of news we have, if you don't mind. So the first thing I do want to share is last week we spoke with Yuval. Cilium layer 7 policy with Istio. So we have the steps now if you're interested to try what I demoed last week. The biggest news this week is Kubernetes Gateway API graduates to beta, and there is an initiative from the Kubernetes Gateway Network Workgroup. This initiative, so make sure to check that out if you're interested in this topic. All right. With that, I'm going to have our attention turning to Keith and talk about GraphQL. So just get started. I'd like to ask you what exactly is GraphQL from your perspective?
Yeah, so like GraphQL, I think it's best to baseline GraphQL as not this like complete departure from how we've addressed data in the past. GraphQL is a type of API. So we know about gRPC and REST, or maybe going back a bit further, like SOAP-based web services. These are programmatic sort of interfaces to data that might be in a database or an applications domain model, right? And we use these interfaces to query that data and maybe update that data, like, update it, delete it, create it, that kind of thing. So GraphQL came around, and it takes a really interesting sort of approach with how we've done that classically, which is it puts the client in control. And you touched on this in the intro, that the client is in control of what data it consumes from the API, which is totally different from REST, for example. From REST, what you do is you probably have a database, and then you create a resource from that database. And then when a client queries that with a GET, they get all of the data back, right? And maybe for a given, maybe it's a mobile app or a single page web application, maybe they have to call 5 different APIs and get all this data back, and then put that together and pick pieces out of it. And in GraphQL, the client basically says, here's the data I want. And it's up to the server and the backend infrastructure to go and query that data and bring it back to the client.
Yeah, it's really interesting. When I play with GraphQL, I've been actually learning GraphQL myself. I kind of think, tell me if this is the right way to think about it. I kind of think GraphQL as, like my SQL commands or any of the database query language, but somehow made it available through HTTP calls. So instead of I need to go to the database client calling my SQL command, I can actually going through calling through HTTP request and also using GraphQL Playground to play with my data. Is that kind of
Yeah,
a
no,
reasonable way to interpret that?
yeah, I think it's actually it's very close. That's a good way to start from it, in that you have a dynamic query language at your disposal. Another thing that's very interesting is, like in SQL, you can have a describe command that basically tells you about the tables or the scheme of the database that you're interacting
Yeah.
with, right? And in GraphQL, it's a requirement by the specification that every API has a schema that's defined with something called the schema definition language, or SDL,
Mhm.
that describes that API endpoint. And this is a huge bonus compared to what, like, SOAP had WSDL, right? REST has Swagger, Open API, but none of those are required, right? So people, how they formulate and structure their API and whether they publish documentation or not, it's a little bit of a wild west kind of scenario, right? Whereas in GraphQL, you cannot have a GraphQL API without having that schema definition.
Yeah, I can see the schema definition would be very helpful to help end user to figure out what is the query they can build on top of with.
Yeah. And I would say the other really interesting aspect of GraphQL is, because it's a data graph, the actual sort of joins and compositions between multiple data sources on the back end are actually the responsibility of the back end developer, the person standing at the GraphQL API. The client just navigates the graph. So they're not doing joins or any other type of correlation or foreign key relationships at the front side. They're just looking at sort of a linear data graph, and they're going and querying whatever they want from it. In database terms, you're probably using like a database virtualization technology or some other view layer that's aggregating that on the back end. But GraphQL just kind of takes that completely out of the picture and makes it easy for clients.
Yeah, so that brings to my next question. I think from a client perspective, you kind of explain GraphQL is very friendly, right? There is mandatory schema that's available for me to help me figure out what query or mutation I need to build. And so why GraphQL, particularly
Oh, Lynn, if you can hear me, I think maybe your network is having a small issue. For anyone watching live, we're just going to wait for Lynn to rejoin. She just dropped for 1 second. So thanks for your patience. We will be right back.
hey, Keith, I am so sorry. I think there's, yeah. Okay, go ahead. Were you able to hear my question? I'm on my hotspot. Hopefully it's better.
Yeah, right on. No. So it could be that the audience, didn't hear it. So I'll play up to what I heard before you dropped, and then you can let me know to finish it. So you were saying, we talked a little bit about what GraphQL is, and I think we were kind of leading into sort of the why of GraphQL. Like, is that where you're going with the question?
Yeah, and particularly I want to have your perspective why GraphQL for backend developers.
Mm-hmm.
Because you can, the way you explain to me, it sounds like they need to do actual work
Yeah.
to enable GraphQL. So
Yeah.
curious on your thoughts on that too.
Sure. Yeah. So if you don't mind, I'll give like maybe a two-part answer there. So the first part is like why GraphQL in the first place. If we go all the way back to, I think it was around 2012, Facebook was developing a native iOS and mobile client actually for both platforms, Android and iOS. And they hit a ton of issues leveraging their existing REST APIs. And the reason why is something we talked about earlier, which is these two concepts, underfetching and overfetching. So in GraphQL,
Mm,
overfetching means when I'm calling a specific GraphQL API, I might be getting way more data back than what I need. And this becomes really important in maybe a mobile client that could be like resource constrained, has little memory, it like can't take in like a 5 meg payload, especially back in 2012, right? Like we were still the phones were a little bit lower powered maybe. And so when you're overfetching this data, you're just like flooding the memory of that device, and it makes it very difficult to have an optimized and performant app. So you don't want to overfetch. When you call, you just want the data you asked for. And
yeah.
then underfetching, the corollary of this is just as bad, because that means that you're making multiple network round trips, right? So aside from being resource constrained in terms of memory, we know
Mm,
phones back at that time in terms of network speeds were not amazing. Even today, in more remote locales where there might not be great service, you don't want to be fetching a ton of data and making multiple round trips to the server. It kills the latency there, just kills the responsiveness of your mobile app, right? So Facebook
yeah.
hit all of these issues, and they came up internally with what would become GraphQL, which is putting the client in charge of the data they're addressing, right? And then ultimately, I think around 2015, a spec was put out in the open, or sort of like a definition of that. Ultimately, that became the GraphQL Foundation, and became a widely deployed sort of specification for GraphQL. Now,
Mm,
the second part, that was the first part of your question, of sort of like why GraphQL in the first place. And that's, everybody feels that pain. In fact, all front end developers feel that pain. If I'm creating a single page web app that has a card layout of various items in a store, let's say, I might be pulling that from 5 or 6 APIs. I don't want to keep track of every API I have to talk to and get all this data. Like, I have to understand all this data and rationalize it, how it connects, and the relationships between
mhm.
the APIs. So I would say the most acute pain that's felt is in the front end developer community. Okay.
Yeah,
The
definitely.
corollary of that, though, is what you were mentioning, is like GraphQL isn't free, right? Someone has to stand up
Yeah.
and develop this GraphQL API so the front end devs can actually invoke it. And the question is, who's doing that, right? Do the front end teams now assume responsibility for back end API infrastructure? Do existing REST API and gRPC and SOAP-based, API or web service developers now start doing GraphQL APIs? Are the platform teams responsible? It's we see that all over the place. Actually, there's not a clear definition of that. And I think another aspect of that is, while the sort of benefits to the front end developer are very clear, I feel like the platform teams actually don't realize at this stage how beneficial GraphQL can be for managing infrastructure, right? From a security, resiliency, like traffic shaping and routing standpoint, there's a lot of
Mhm.
really powerful platform concepts you can apply to GraphQL that I think the market is just realizing now and starting to embrace.
Yeah, I'm totally with you on that. I think on the client developer side, the advantage is so obvious, right? I just had a network issue, right? What would be even nicer than I just pay exactly the data I need, and then that's the data transfers through my network, right? Assuming nothing is free, you have to pay for, then you always want to pay exactly what you wanted, right?
Yeah.
On the backend side, personally, I struggle a little bit myself too as I was learning GraphQL, because I find out, it's actually pretty hard to kind of, put the data you have and then make it a GraphQL server and make it available so that your client developer can use, right? Because there's a terminology you have to learn, there's a Java you have to write, and yeah, so So totally, I think there's probably some confusing in that place. And also, I think there's a lot of tooling out there. Just follow like Get Started tutorial. There's Apollo. I think there's also Facebook. Maybe have some tutorial. There's also library for different GraphQL. So I personally find it a little bit overwhelming.
Yeah, yeah. And I mean, there's great resources out there. I actually think the GraphQL Foundation have done an amazing job. There's the GraphQL spec, which is pretty hardcore. I mean, it's actually very well written, you know, and understandable, but like, you don't want to start there, right? Like that's getting really into the nitty gritty. They've actually done an amazing job just with some high level docs showing examples of just walking through the value proposition of GraphQL and the, you know, top level concepts there. A ton of companies use GraphQL today. I mean, famously, GitHub has a public GraphQL API with really great support and examples of how to navigate their graph for GitHub as a developer. So I think you can rely on resources like that as well. And then vendors that are in the GraphQL space all have examples of how you're using their frameworks to do it. And as you mentioned, that can involve writing code. Maybe you're using a server like Apollo, for example, to create a server in a node-based environment. You might be using a framework in like Go or Ruby or Java. Actually, I think the Spring Boot community or Spring community just announced GraphQL support there. And then there's options like we have at Solo, which is that we can actually embed that intelligence directly into Envoy proxy, right? So a lot of options out there to really get started.
Yeah, which is overwhelming with lots of choices too.
Yeah.
Yeah, we have our first question from the audience. Hey, Wenki, thank you so much for joining us. So the question is how GraphQL will work internally. And if data distributed in multiple databases, for example, does that reduce database costs or does it reduce client cost?
Yeah, this is an excellent question, and it hits at a bunch of key concepts for GraphQL to begin with. So let's start from the client perspective, and then we'll work our way all the way to the data source. And so to establish that lineage, let's assume we have a client, okay? We have a GraphQL server, and then we have a set, one or more databases behind the scenes, okay? So from a client perspective, it reduces database calls from the client because the client is only making one call to the GraphQL server. So it's always one single call and you get your result there. So one round trip. So that's definitely saving the client there. On the back end, the interaction between the GraphQL server and the database, you're always going to need at least one call, you know, to get the initial data or to insert or create, right, or whatever. But the real advantage with GraphQL is it can optimize that traffic in a way that clients generally wouldn't have this level of sophistication. So a very common example is caching and batching. Excuse me, that's tough to say back to back.
Yeah, so
in the GraphQL server layer, right? So data loader, as an example, is a very popular project in this space, but there are other implementations as well. And what that does is it says, hey, if I've already fetched some data from an upstream data source, don't call that again, basically. Or if I know I'm going to make several calls to a single upstream data source, batch those together and make them at one time instead of a bunch of individual calls. So not only are you saving round trips and network from the client to the GraphQL server, but you're also optimizing the interaction between the GraphQL server and the upstream data sources.
Interesting. Is that part of the spec, the hard to pronounce fetch and cache or something?
Yeah. So that is not. That's actually up to the implementations of the various frameworks and GraphQL servers that do that. I would say by convention, it's very popular, right? Like a lot of the aspects around GraphQL, it's so broadly adopted that you start to see conventions sort of develop around the edges of the spec. Caching is a great example of that. Data loader for caching and batching the resolver tier, like client-side caching. There's just a lot of standard conventions for doing that in the GraphQL community.
Very cool. I hope that answers your question, Wenki. If not, please leave a comment on the side and let us know. Thank you for that great question.
That's very cool how the question pops up there too. I feel like I'm in a professional show, Lynn.
Yeah. Well, thank you. I love this platform. It's just so nice to allow us to interact with the audience. All
Yeah.
right. Let's see. What's our next question? I think you kind of touch on how does GraphQL work. I don't know if you want to elaborate a little bit on that.
Yeah, let me go ahead and share my screen real quick.
By the way, nice feedback from you. Thank you, Wenki.
Oh, awesome. That's great. My pleasure. So let's see here. Let me share my screen.
All right.
All right, you able
I
to see
can
my
see
screen
your
now?
screen. Yes.
Okay, great. So let's go ahead. I'm going to go ahead and clear this out just so we surface with. So what I'm looking at here is a popular open source framework, JavaScript client-side framework called GraphQL. And what GraphQL allows you to do is to interact as a client with the GraphQL API. I'm going to use this client here just to explain a little bit about GraphQL in case anybody in the audience is unfamiliar with GraphQL. It's best to see by doing, right? So
Yeah,
what I'm going to
totally.
do, yeah. So let's take an example, and we'll see this a couple times. I'll probably do two parts of this demo, but I just want to focus on GraphQL stuff right now. So what I'm going to do is a very common use case is taking an existing REST API or a set of REST APIs and putting GraphQL in front of that. Okay. So in this case, I've deployed a sample API called tracks, which has the normal CRUD operations you'd expect inside of for any resource in REST. So create, like get, post, put, delete, right? And then a pretty standard resource object model there for a given track. It's got all this, it's got an ID, so you can reference it by ID, and then a bunch of other fields that apply to it. They're not really that important, other than to know that, hey, when I call this REST API and I get a track, I'm getting all this data back. I have no choice as a client. Okay. So let's go, oh, excuse me. So let's go back over to GraphQL. And first and foremost, let's look at the first on the right-hand side here. We can see the Documentation Explorer. And what this is showing is just a pretty markup version of a GraphQL schema. As we said, all GraphQL APIs must have a schema. And there's a great tool chain built around that to actually help you navigate that schema to understand how you're going to invoke a GraphQL operation. Here we can see that there are actually two root types defined. One is a query. This is how I fetch data. And one is a mutation. And this is how I mutate data. So like creating data, updating data, deleting data. Okay. There's a third type called subscription as well. It's less commonly used, but that's sort of like an event-driven long poll query for basically shorthand description of what it is. It gets a bit more nuanced, but it's sort of like a push query. Let's call it that. So when I go look at query, for example, I can see that I have two methods here, and these you can naturally map these to a REST API. One is I have get all tracks. So this would be like a get call on the root of the tracks resource. And then I can get a track by ID, which I would normally just do that with a path parameter that includes the ID of a track. But here we can see a first class representation of two query fields, get tracks and get track. So what I'm going to do now is I'm actually going to close that up, and I'm going to go look at our little explorer here. And again, because we have a standard schema, we can build a bunch of useful tooling around that, and GraphQL does a great job of that. So if I'm going to get all the tracks, I can list all the data that's available to me. And again, I don't want all of this data. So I might just want, let's say we want to get the ID, the topic, and the, let's get the title, okay? And so I'll go ahead and run that query, and I can see returned here are a bunch of individual tracks with just the data I requested. At any point, if I want to add created at, I can run it again, and I see that data. If I decide I don't need it, run it again, I only get the data I asked for, right? So really, really powerful. And you can imagine this is sort of a simple example of a single GraphQL API in front of a single REST API. But what if we have 10 or 20 REST APIs or individual GraphQL APIs I'm bringing together into a federated or unified graph? Now this optimization becomes incredibly important because we only want to call specific upstreams when a client requests data for them. Does that make sense so far, Lynn?
Yeah, totally. In
Yeah.
fact, just this morning, I was playing the same client you are showing. Certainly, my schema was a very simple, like hello world. But the UI you are showing, I just want to make a point. Even though you have Glue Edge in there, it's nothing related to like it's just an open source project Glue Edge is using, which I got it running on my machine, without any of the Glue products, which is very nice too.
Absolutely. And that's one of like the most powerful things about GraphQL is that there are so many GraphQL clients out there. Like there's the, GraphQL Sandbox, GraphQL Bin, Apollo Studio, Altair. Like there are so many client frameworks and they all work with, no matter how you've implemented your GraphQL API, they all work because of the strength of the specification and the portability of that format of the SDL to work with all client tools.
Yeah. So in your example, how is the data gets resolved?
Yes, great question. So let's actually go into part 2 of the demo. What I'm going to do is I'm going to go ahead and let me share my screen here real quick and just I'm going to show just one example of this. As you mentioned, there's a vibrant ecosystem. There's a whole bunch of different ways to create GraphQL APIs. We're just going to show, for sake of example, how we do this in Glue. And then, you can apply these same principles, though. You can look at creating these in other languages or frameworks as well. And maybe we'll use this as a springboard to talk about maybe some of the unique advantages for platform teams and backend teams that you might want to look for. So right now, I already have this GraphQL API. I'm going to go ahead and tear all this down. So let me come back over here and delete the various resources around this. Okay, great. And then I'm going to go ahead and first I'm going to, so let's just go back to APIs. We see we have no GraphQL APIs anymore. And if I come into my set of services, I have pet store deployed, but nothing else. I'm going to deploy this REST example that has the tracks API. So let me go ahead and deploy this example. And now when I get services in Kubernetes, I should see I've got the REST example. And a really interesting thing here that Glue does is it can automatically discover these REST APIs, and it can break them down and tell us exactly the resources and the functions that are available on them. And we've tied into that with the Glue platform to actually automatically generate GraphQL APIs. So as a platform team or a backend team, I don't need to write any code here. I'm just basically an app dev team has deployed a REST API, and we're automatically creating GraphQL APIs from that. So if I come back into our UI here, we can see that we have the full schema definition with get tracks and get track and all the various mutations and the type definitions all available to me just as a native GraphQL API. It has the full schema that we've generated for it and everything. But to get to your specific point, Lynn, so how does this all map up? When I called get tracks before, like how did that map to my REST API? So in our case, what we do is we actually just have a reference to the upstream here, which is the name of the upstream in our environment, which is default REST example. And then a bit of configuration that gets applied that says, hey, for that REST API that's part of that upstream, what's the HTTP method and what's the path that you want to invoke? And with that information, we call the upstream REST API and then map that data directly onto the schema definition, the fields in the schema definition. This can be very flexible. This can declarative syntax. You can do request and response transformations if you're looking to fit data or change data either to the upstream REST API or back in the response. So this is a style we call declarative configuration, which is in contrast to a lot of the existing market is programmatic. It's imperative, right? And you're writing code to do this. And just to
Yeah,
follow up,
totally.
yeah.
Because I was trying to figure out how to write code for something I was trying to do really simple. In fact, I was trying to display like a couple of quotes from different speaker. It sounds something simple, but I was not very familiar with Node.js, so I actually haven't figured out how to do that. So if I understand you correctly, Keith, let me replay what I heard from you, right? So you took this REST example, which has Kubernetes YAML. You deploy it into your Kubernetes cluster, and essentially you provide a GraphQL schema. That's a additional you have to provide. And inside of that schema, you somehow kind of tell Glue how you want each field to be resolved. And Glue kind of automatically figure that out for you because you basically said for this particular field, let's say message, for example, this is the REST corresponding REST API to get the value for it.
Yeah, and it's actually, I'm glad you touched on this because I sort of glossed over something that's an important detail in that demo. There are really two ways you can leverage this declarative configuration. One is our control plane basically can introspect the existing REST APIs and gRPC APIs, and using their existing contracts, like an open API definition or the proto definition for gRPC, we can actually automatically generate the schema definition. So you don't have to create a schema
Oh,
definition. We can
wow.
automatically create that
Okay.
and wire up all the resolvers, okay? Now, that's really useful in use cases where you just want to take an existing API and you want a GraphQL equivalent, right? You might be exposing
Yeah.
that directly. You might be stitching that together to create a unified graph with a bunch of other things, right? But it's very easy to do that auto generation. But we also, that auto generation is always just creating Kubernetes custom resources that have the two things that you mentioned, a schema definition and the resolver configuration, right? If you have maybe a more advanced example where you're doing some, transformations, manipulation, combining multiple upstream APIs, you don't have to use automatic generation. You can just create that configuration descriptor yourself. We have a UI that does it, but you can always just do it in the text editor of your choice. And that gives you a lot more control on how you create that GraphQL API and the shape of your schema definition.
Yeah, that makes sense to me. So essentially, the example you show was automatic. I assume it's automatically discovery of the REST API and then automatically generate the schema and automatically think out the resolver. But as an alternative for advanced user, they may not want everything from REST to be converted to GraphQL, right? Maybe there are some fields that's legacy, or maybe they need to weave multiple services, REST services into one single graph that they need to kind of tell us how they want to do that together. That's when they go to the advanced route by providing schema definition themselves.
Exactly. And we have another example that we can share afterwards, I think, in the notes for the Hoot episode. But like if you look at the Istio book info example, that's a pattern that's widely known in full stack development circles, known as backend for front end, right? So you have multiple REST APIs that exist behind the scenes, and then you create a new REST API just for a specific client. So maybe it's a mobile app or a single, page web application or what have you. GraphQL is the perfect technology for implementing BFF because you're not creating a specific BFF API for every client. You just have one API and all clients can consume it in the way that they need to address the data. So what you were saying, the more advanced use case there would be exactly that type of pattern with BFF,
Yeah.
where I have a single GraphQL API, it's talking to multiple REST or gRPC upstreams.
Yeah, makes sense. We have another question from the audience. Hey, Bancho, thank you so much for joining us. I think it might be very late at your time, if I remember correctly. So the question is there federation support out of box for native GraphQL API?
Yeah. So great question. And so I'm gonna answer this directly, but for other people in the audience that might not know some of the terms being used, I'm gonna explain some background and then I'll lead up to the answer. So when you create,
just really quickly, I want to share with you, he had another message so you have the context, especially automatic schema discovery registry for new service versions.
Yeah. So let me build up to that. So there's, and actually let's add the federation stitching point is a really interesting one. And I think a follow-on question is more about change management and what controls and governance controls are in place for things like breaking changes that might impact maybe a federated graph. So we'll split those two. But to explain these terms for other folks that might be like, what is all this, terminology that just got thrown out there? So we were talking a lot about creating a GraphQL API, like a single one from existing REST or gRPC. A common pattern as you get more evolved in your adoption of GraphQL is that you've collected multiple GraphQL APIs, and then you want to take those and you want to combine them into a single graph, okay? So a lot of times this is called, those individual GraphQL APIs are called subgraphs because each one of them is a small part of your unified graph, okay? And then that bigger thing can be called a super graph, a unified graph. It could be called a federated graph. It could be called a stitch graph, okay? But all of these refer to the same thing, which is they're all a unified graph of all your individual subgraphs. In the market, there are two prevalent technologies for creating that unified graph, okay? One is called Apollo Federation, which, big surprise, is created by Apollo, right? And the other is called stitching, which, interestingly enough, was also created by Apollo originally. Ultimately, they decided to go with Federation, but the community, like the guild and others in the GraphQL community, really liked stitching still. And so they picked it up and evolved it and created a great support in the community for stitching as well. From my standpoint, the real difference, both of these are equally capable and they both get you to a unified graph. They ultimately just have two different perspectives. From the standpoint of federation, every graph, subgraph, is aware of the unified graph. So basically you have this very sort of egalitarian approach where every individual graph is saying, okay, this is the super graph or the unified graph I'm integrating with. Here's some keys and other directives that are actually linking me back into that unified graph. Whereas with stitching, it's a bit more of a compositional model where instead of everyone owning the combined graph, maybe you have a dedicated team that owns the composition of that graph, and they're creating the stitching config that's bringing in those subgraphs. Now, a unique advantage with that approach is that potentially in a federation model, the individual subgraphs are not viable GraphQL APIs on their own. They're actually created to contribute to the unified graph. Whereas in stitching, generally, all of the individual subgraphs are like viable standalone GraphQL APIs, and they get combined into a stitch graph, right? There's lots of nuances, but in broad strokes, like that's basically how I look at it. So getting back to the question is, do we support federation or existing federation of GraphQL APIs? And the answer is, we support stitching as a compositional model for creating that unified graph, but stitching those GraphQL APIs can be a federated graph. So if you have an existing federated graph, you could pull that directly into your stitch because that's just a GraphQL API at the end of the day, right? If you have existing GraphQL APIs implemented in other frameworks, we can stitch those together and put them in our unified graph as well. So we have not elected to implement Apollo Federation at this time. When we talk to customers in general, they're very happy with using stitching. But if we see a lot of community demand there, there's no reason why we couldn't implement Federation as well. So I hope that helps answer that question. There was another element around discovery. So we support discovery of gRPC and REST APIs. We don't support discovery today for GraphQL APIs simply because you create a resource that just points to it and provides a schema. So it's like a very easy type of thing to incorporate into a stitch graph. But again, if we get feedback that would be super useful, that's definitely something that we can implement. It would be pretty trivial to implement. The change management aspect of this automatic schema discovery and registry. So this is one of the things we really like about stitching is it puts you in control of referencing the upstreams that you're incorporating into your graph, the subgraphs that you're pulling in, right? So you can label and sort of version those however you see fit and use that to drive the life cycle of how you incorporate newly released versions of those subgraphs. We also implement support and we actually leverage GraphQL Inspector, which is another great Guild community project, to have governance controls around what's allowed for changes to schemas. One of the biggest concerns here with a unified graph is that a subgraph basically busts the unified graph by incorporating a breaking change, right? And so these change controls allow you to set your tolerance threshold for whether you'll accept a breaking change in the first place, what counts as a breaking change, and this type of thing. So,
yeah, very cool. That really clarified my confusing around federation and stitching. So great explanation. So I hope that answers your question too, Bungie. Please leave us a comment and let us know if you have any additional questions. Keith, I do have one question for you. As you were speaking, the user who does the stitching, right? Do you think that's like a platform team from a persona perspective?
My guess in our persona definitions, like I would think that's more an app owner, maybe, sort of like it could be data architect, but it really could be anything, right? Like a platform, like we deal with a lot of cloud engineering and platform engineering teams at Solo, basically.
Mhm.
And, the almost universally in those teams, they want to take the state of their platform, check it into Git, and then use that to roll out to all of their environments, basically. And right, and that's exactly what we enable. So absolutely, this could allow responsibility for platform teams to take this on. I think more importantly, it sets up a situation that even if another team owns it, it's a resource that can be controlled with RBAC and integrated with other policy resources that platform teams
Mm.
do have access to. So when you start looking at authentication, authorization, rate limiting, protections, defense in depth, and this kind of thing, the way that we're pushing it from a platform standpoint is 100% compatible with all of those approaches. You're not writing extra code to integrate those capabilities, right?
Yeah, makes sense. So this could be owned by the application owner, but in the event if the platform team choose to have the control, they could get the control back and own that for the app team if they wish to.
Yeah. And I'll just mention, hopefully this has been clear in the way I've been answering the questions, but I just want to state it explicitly. There's not a right or wrong way to do this, right? Like if you're writing codes with GraphQL APIs, that's great. Like if that's the way you want to do it. If you want to use declarative config, that's great too. One of the really nice things about the GraphQL community is it's so inclusive, it's so open, and everyone's participating, and contributing. What we're trying to do is just make it a lot easier for teams that want to align their GraphQL infrastructure to their platform architecture. We want to make that as easy as
Mm.
possible, right? And in our customers, we definitely see cases where they have a large percentage of their existing GraphQL APIs that can be implemented with a declarative approach. And there's some very special case things where they want to use a specific framework and how to handle it, talk to a specific database, do some specific coding, for lookups or whatever. And that's fine too. All of that can still come together into a combined graph.
Yeah, makes sense. We just got, by the way, we got thanks from Benji. So thank you for answering that question. We got another question also from you. The problem with
Oh,
federation is that there's a need for central gateway and all subgraph have to be up and running or the gateway would not work. And doing blue-green deploy is not possible.
this is such an insightful question, and it's interesting because we were just discussing this a couple months back as we add support in Glue Mesh for GraphQL, and there's a couple things there that we hit on here. One is that all of these resolvers and resources you're talking to resolvers should have flexible semantics around traffic policies so you can shape and redirect that traffic.
Mm.
So if you're rolling out a change to a REST API or changing some of your resolver logic, you can test that. You might want to initially, basically have a dark launch and not include it for anyone. Then use specific headers and just route specific traffic to, and then you'll maybe get an aggregate of like 20% of my traffic I'm bleeding over. You want to do all of these things. And of course, at any stage, be able to roll back atomically to a known good state if things go wrong, right? So I think that that's absolutely something enabled there. And then another key aspect that's being raised here is that in a mesh environment, the client sidecar is actually what executes the GraphQL request, right? So unlike a traditional gateway-based implementation where you might have a service in your mesh or your environment that's calling out through a gateway and coming back in to talk to services that are already in that same namespace workspace cluster, here that all executes in the client sidecar, which is a huge simplification and provides a lot of power in our GraphQL implementation.
That's an interesting point. So that the client sidecar could potentially have intelligence built in to do like canary rollout and dark launch that you are talking about.
Yeah, so it's all executing against the route tables that are defined of where those upstream destinations are that are the APIs, right? And so
Yeah.
it's all like ultimately all of this, a huge percentage of our implementation is actually not in the control plane, but in Envoy itself, right? So wherever using Envoy, whether it's in a gateway scenario for north-south traffic or east-west, all of like the really heavy lifting is in Envoy, right? Then we take that envoy and we say, hey, the envoy is not executing at the edge as it is in a gateway scenario, but it's executing in a client sidecar. In both cases, it's just a dispatch, basically. You get a single GraphQL request. The GraphQL engine that we have in the proxy basically interprets that request, validates it, right? And then maps it to resolvers. That's just a dispatch mechanism of where that request flows upstream, right? So
Yeah, thank you so much for the excellent question.
yeah,
It
great.
really showcases, why, there's a value building GraphQL as an extension on top of Envoy, so we can leverage all the routing, or even the security capability from Envoy to handle exactly the question you mentioned. Yeah, awesome. Thank you so much again. Let's see. I guess we are almost getting towards the end. Um, can you talk about how do I get started with learning GraphQL as a user? Um,
Yeah, I'll kind of give just to reiterate something we said earlier is I would definitely start with a GraphQL foundation and and just the high level docs there just to understand what GraphQL is. And then I would say based on the individual audience members, are you an app developer that has experience with JavaScript, or you're a Go developer or Ruby, or and you want to write code to implement GraphQL? Okay, then that's a path, and you can go to that framework of your choice, and they'll have great getting started material on how to get going, right? If you're a platform team, a cloud engineering team, or even I would say a front end team that doesn't want to have to write and maintain and operate a GraphQL API, then maybe look at what Declarative has to offer. And in
mm.
fact, maybe do both and compare and contrast them on what fits best for your needs. So we have some great, from the declarative standpoint and doing it in Glue, we have some great getting started guides that we can link to from the show notes that'll get you up and running and starting to play around with this. And we love feedback. So, on Slack, reach out to us and ask us questions. We'd love to interact with our community.
That's awesome. I believe we also have a workshop maybe on GraphQL. That might be a
That's a
great
great
way.
point. I'm totally sleeping on the workshop, but yes, we have a fantastic workshop. So you don't have to set up anything locally. It's all browser-based in the Instruct platform. We run those regularly. I don't know when the next one is, but it's on our events calendar. So, you definitely get hands-on on those.
That's awesome. Yeah, thank you so much, Keith. Is there anything else you want to add before we wrap up for today?
Only thing I'll say is if you haven't used GraphQL, you definitely owe it to yourself to give it a shot. We see it soaring in popularity. They have like monster adoption stats in the JavaScript community of 98% of developers are aware, crazy high satisfaction levels. Every year they do the API landscape, GraphQL continues to creep up, which is a very mature landscape when you think about, FTP and SOAP and all these others interfaces for data that have been there forever, decades and decades and decades. The fact that GraphQL has grown so quickly, it's definitely, if you're not using it today, it's coming to an environment near you, and so this is a great time to get educated on it and understand how you're going to deploy successfully.
Yeah, totally. We have last question from our audience too. Love it. Thank you. Does Portal support GQL documentation?
Yeah, so right now, the portal that we have today is just for REST and gRPC, and we actually, because the interfaces for GraphQL, the whole API registry and looking at the type tree and the Explorer are a little bit unique to GraphQL, but they're not so unique. And so what's interesting is that as we're adding portal support and this is a little bit of a preview, but in a future version of Glue Gateway, we're updating our portal, and you're going to start to see all three of those APIs occupy the same level, right? So you have a single API catalog where you see all your gRPC and REST and GraphQL APIs, and then you go to the appropriate documentation and client tooling to invoke each of those. So the answer to this directly is no, we don't add this in Portal today, but the next version of Portal is going to have GraphQL support along with gRPC and REST.
Awesome. That's great. Thanks so much for that last question. We had fun for sure answering your questions. Let's see. All right. So Keith, I want to take a minute to thank you. I feel like I've learned a lot about GraphQL from you, how, the landscape works, how to get started, what's the difference between federation to stitching, why, we go down with stitching, automatic schema generation, manual generation, how to, wire up the resolver to the REST API. It's just a lot of learning done for me. So I really appreciate the chat.
Thank you very much for having me. This is awesome, and thanks for everyone that asked the great questions. This is a lot of fun.
Yeah, I really appreciate all the audience tuning in and ask these questions. It really got us thinking and make the hoot so much fun. So it's really for the audience that like you. Without you, there's no hoot. So yeah, so folks, if you find this interesting, please give us a thumbs up and also subscribe to our channel so you don't miss any of our future hoot episode where I, talk to different experts on different topics. So thank you so much, everyone, for joining. Thank you, kids, again. Bye
Thank
now.
you. Bye.